All right, good morning. Thanks for joining us today. If you're in person or online, we're going to be working on sections 301 through 306. And yes, this is easier than logarithms. So if you have printed out the notes already, I gave you a formula sheet in addition to the slides for today. It looks scary, but it's not that scary. So everybody's going to take a deep breath and just tell yourself this is easier than logs, I promise. So you're going to hold me to that, and that's totally fine. So I'm putting up this new slide because I didn't tell you guys last week that this Friday we're celebrating Pi Day. Yay, Pi Day. Pi is approximated to be 3.14, so it's actually celebrated nationally on 3/14. 3/14 happens to be Saturday, so I'm not going to make you guys come in on a Saturday. So instead, we're celebrating it on campus this Friday. So we're going to celebrate it a day early on 3/13. Anyone who attends in person, you're going to get 5 points of extra credit. I'm going to be setting up the high school lab with different stations. You guys will walk through the stations, kind of completing activities at each station. Once your paper's filled out, you get your extra credit. It's tons of fun. I even told the students in person, I have a special t-shirt for Pi Day. So I love Pi Day. So that's happening on Friday, and I hope to see you here on campus. The lab's going to be open from 10 to 12, so it's kind of like a drop-in, do the activities, and then leave. There's not a specific time you need to show up. The worksheet will take you approximately 40 minutes, so please arrive no later than 11:20. That way you would make sure that you finish on time. So anytime you can arrive between 10 and 11:20. Does that make sense? Super fun, working in teams, while music going, you know, whole 9 yards. So that is this Friday, 3/13, between 10 and 12. Okay. Week 9 essential questions. So whether you are in person or you're at home, please take a quick minute and copy this down. So those of you that are in person, we will answer that with our partner at the end of today's session. And if you are watching from home, you will need to answer it in the week 9 Dropbox. So it says, what is the difference between an arithmetic and geometric series? Please provide an example set of each type of numbers. And actually, I want to change the word series. Can you guys cross off the word series? It really should say sequence. We're going to really focus on sequences today. So sorry about that. Can you please cross off the word series? And we're going to change that to the word sequence. So there's a difference between a series and a sequence, and we'll talk about what it is in a moment. So for Unit 3, these are the first couple sections. For today, we're really going to focus on these top 3 sections. We're going to briefly touch on that last one, the summation series. But by the end of today, what I really want you to know is what makes something an arithmetic sequence versus a geometric sequence. So when I say sequence, here's what I mean. You guys have been dealing with sequences probably since 1st and 2nd grade. That's a sequence. What makes something a sequence? There's a pattern to it. So today it's going to be all about finding the pattern, which hopefully we can look at this one and we see what the pattern is. And then how do we write the formula for that pattern? So that's where it gets a little tricky, but not too bad. I gave every one of you a formula worksheet, so if you guys can keep that worksheet handy. If you look at the worksheet, the top 2 boxes are for the arithmetic sequence and geometric sequence. The bottom 2 boxes are for series. Remember how I said we're not really doing series today, we'll do it just a teeny little bit, but that's going to be coming on Friday and early next week. So keep this sheet handy. So which ones are we using today? The top 2. Which ones are we using on Friday and next week? The bottom 2. See how they're labeled pretty nicely for you. So let's start trying these. Again, what we're going to be focused on today is we are going to be finding the pattern. And then we're going to be writing the equation for the pattern. What's the equation look like? They're the ones on your worksheet. So we're going to take the equation and just fill in the numbers that we know to be true. So let's try a few. Oh, and here I'm showing you the worksheet. So here's the portions I want you looking at today. So it's the top 2 boxes, your arithmetic sequence and your geometric sequence. There's a lot of crazy letters going on there, so let's kind of take a look and see what we see. A sub 1. Anytime we see an A sub 1, that simply means your very first term. So let's go back to my example. I had my 1, 3, 5, 7, dot, 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 dot. What would be my first term? What's my A sub 1? 1. See how it's not a hard question, it's not a tricky question, it's just us recognizing, oh, A sub 1 means the first term. The second one is where it sort of fools students a lot. What that means is the previous term. We'll talk about that in a minute. So if I ask you, here's A1, A2, A3. If I ask you what's the previous term for 5, which one came right before it, you would say 3. Okay, so we're okay with what previous term means. It means the one right before it. It's an A with a little sub n minus 1. When I say sub, I mean like a little, you know, like we're used to exponents, right? So today we're going to have some little sub numbers.
What if it's the previous term of the first term? It just remains the same.
We're going to try that in a minute. Yeah, the question was, what if it's the previous term of the first term? And technically, if this is a pattern, couldn't I continue on the other direction too and find that term? I can. We'll talk about how I do that in a couple of minutes. Then it says that D represents common difference. Wait a minute, I only see D in one of these kinds of sequences. Can you guys take a peek? And then R says common ratio, but wait a minute, I only see R in certain sequences. So where are you going to have a D? You're going to have a D with your arithmetic. See how they both have D? When am I going to have an R? With geometric. So we're going to talk about how do I know if it's a D or an R? How do I know what equation to use? We're going to answer all those questions today. So we're going to try one. So sequences and patterns. A sequence is just a list of numbers that follow a pattern, which again is what we've been doing since first grade, second grade. Each number in the sequence is called a term. So A sub 1, A sub 2, A sub 3, dot, 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 through A sub n. That means any number, right? Any term I could ask for, I could plug in my number. So here's an example. If my sequence is 2, 5, 8, 11, 14, what's your A sub 4 term? Okay, so I heard an 11. Does anybody else have an idea? Do we agree, disagree? We agree? Okay, perfect. So this would be your first term, second term, third term, fourth term. So your fourth term, you can say this two ways. So we could say A sub 4 is 11, or we could say the fourth term is 11. Everybody okay with both ways of me saying that? So A sub 4 means, what's your fourth term? 11. You're just going to pick them out. Good job. What if I ask you, what's your A sub 5? What would you guys say? 14. Good job. And let's take it a step further. What about A sub 6? Oh, but wait, that wasn't on there, but yet you knew the term, am I right? Because how did you know? You found the pattern. You found the pattern. So this chapter is all about finding patterns. Now, you were able to find A6 really easily, am I right? You just kept adding 3, adding 3, adding 3. What if I asked you what's A100? Oh, do you really want to write out the first 100 terms? No is the answer. So that's why we have these really great rules. They're called the recursive rule and the iterative rule on your formula sheet. So we're going to be using those today. So that way we can find any term I asked you for without writing them all out. Because even if I said, what's A to the 1000th term? Yeah, you don't want to write that out by hand. Even if you had the time, you don't want to. There has to be a better way. So today's about finding that better way. Okay, so we're going to jump in with recursive rule. And it says a recursive rule is a rule used to find terms in a sequence that depends on the previous term. So we'll talk about what that means in a minute. So for example, my sequence starts with a 6. The next number is 5 more than the last one. Would you agree? 5 more than the last one. 5 more than the last one. 5 more than the last one. That's called a recursive rule because you're using the previous term and what are you doing to it? Adding 5. You're using the previous term and you're adding 5. That's called a recursive. So it's just a new vocabulary word for us. So here's actually the formula that represents it, and we are going to be writing these formulas ourselves today. So let's think about why this is our formula. So let's all look on our sheet. This is an arithmetic sequence. We'll talk about arithmetic in a minute. And it says that my formula is a sub n equals a sub n minus 1 plus d. That's my formula. I'm just looking at my chart. Is everybody looking at their paper chart that I handed out? That's the formula. The only number we have to fill in is d. D means the common difference. What was the difference? It's basically saying, what's the pattern? What was the pattern? Add 5. So that's what they did. And you're done. You did the whole formula. That's it. That's it. So this is saying, take the previous term and add 5 to it. Take the previous term and add 5, and you're going to keep getting the next number. So we'll keep working on these.
And that'll always be the same, the first part of the like A.
Yes, so the first part's always going to stay the same. Let's think about why that's true. Let's say I want to know the fourth term. Can everybody look up there on the chart? What's the fourth term in this sequence? Is everybody okay with that idea? He's right. Fourth term is 21. Let's see why this formula would work. Okay, watch what I'm going to do. I'm going to plug in, instead of my n, I'm going to plug in a 4. Everybody with me? So instead of n, I'm going to plug in a 4. So let me make some space for myself down here. So if my n is a 4, watch what happens. Oops. A sub 4 equals a sub 4 minus 1 plus 5. So what I did is everywhere there was an n, what did I put in? A 4, because I wanted the fourth term. So really, the fourth term is going to be the third term plus 5. Oh yeah, that makes sense. The previous term and you're adding 5. So does that work? Do I take the previous term 16 and I add 5? Yeah, that's how I got 21. So whenever we say that the n minus 1 is the previous term, that's why. Because you're plugging in your number and you're subtracting 1 from it. You're getting your previous term. So this will make more sense as we continue to practice. So here's a quick example. It says, write the first 3 terms of the sequence defined by, I'm giving you your a sub 1, and I'm giving you your formula. Is this one filled out on your notes already? Did I leave all those steps on there, or no? I did? Okay. So this one I'm giving to you. So let's try. In my first step, I'm going to say my a sub 1 is 4. How did I know? They gave it to me. Everybody okay with that one? That one's easy. They gave it to me. So how am I going to find a sub 2? And again, I don't like how they drew their steps. So I'm going to do them myself. So over here on the side, can you guys also draw in your own steps? I'm going to put my formula here. So for my a sub 2, I'm letting n become a 2. Everybody see that? It was a sub n, but I'm going to let my n become a 2. That means over here in my formula, I need to let my n become a 2. So let's try. So 3 times a to the 2 minus 1. What is 2 minus 1? 1. Everybody okay with that idea? We're just plugging in numbers. We're just subtracting. It just looks strange because now they're these little sub numbers, which look weird. So what this is saying is I need to take 3 and multiply it by my a1. So that would be 3 times, what did we say a1 was?
4.
a1 says 4. So that means my a sub 2 really equals 12. 3 times 4 is 12. Let's try a sub 3. So everybody write a sub 3. Sorry. So a sub 3 is going to equal 3 times a, but this time it's going to be, remember we're using this formula here, my n is going to be a 3. So 3 minus 1. What is 3 minus 1, you guys? 2. So that's really saying 3 times a sub 2. Didn't we find a sub 2 already? We did. So that really means 3 times what number? 12. So I would get 36. So my A3 would be 36. So let's write my first three terms of my sequence. I had a 4, then I got a 12, then I got a 36. So I'm always using the previous term, and what am I multiplying by? 3 to get my new answer. That's your pattern. We're going to keep trying. Hopefully there will be clarity by the end of the session. I know every time we see something new, it usually takes 2 or 3 examples to kind of really grasp on and see what's happening. But the big idea is anytime you guys see n-1, what does that really mean? The previous term. Always. What does that mean? The previous term, the one that came right before it. So if I'm finding A2, guess what I'm using? A1. If I'm finding A3, guess what I have to use? A2. You're always going to be using the previous term in there to find it. Okay, iterative rule. I don't think I gave you these. Are there no notes under there on this one? Ah, okay, so I gave you the first part. I just gave you that? Yeah. Okay, perfect. So here we go. On the top of your page, do you guys see how you have a recursive rule and then you have an iterative rule, am I right? You have a recursive rule, you have iterative rule. Recursive rule you can only use if you know the previous term. Iterative rule you can use to find any term. So if I say I want the 1000th term, we're going to use iterative rule. Because do you know the 999th term? No, so you can't use recursive. Recursive is only if you know what came before it. So this says an iterative rule can be used to find the nth term without calculating the previous term. So let's underline that. Without calculating the previous term. I'm going to put a huge star by iterative rule because it is so much more useful than the other one. This one lets us find any term, whether it's the 4th term, the 20th term, the 1000th term. So much more useful. So even on your big formula sheet, why don't you guys put a big star by iterative rule? That one is much more useful. Way more useful. All right, so we're going to try one. For instance, if I want to find the first term, which means I'm going to find a sub 1, just means I'm going to take a 1 and I'm going to plug it in. So 14 times 1 plus 1. So my first term would really be how much? 15. That's great. I know my first term. But what if I asked you guys, I want to know my 10th term? That's just as easy as finding the first term because you're going to take your n and you just plug it in. So 14 times 10 would be 140. 140 plus 1 would be 141. Did I need the previous term? No. I love this one. This one's way easier. Way, way easier. If I asked you the 10,000 term, you could find it. Everybody okay with this idea? So iterative rule, very straightforward. You're just plugging in the term you want to solve for. That's it. We like this one. This one's easy. Have you noticed that so far they have been giving us these formulas? They're giving me the formula for the sequence. They gave me this formula for the sequence. Guess what's coming next? Eventually we're going to have to write our own formulas for these sequences. Okay. So let's say, here's my formula, which I think I have the answer whited out on your answer key, right? On your notes? Sure. I gave you the answer? No. Okay. It says, what is the 15th term in the sequence? So let me give you guys a minute. Please find the 15th term for this sequence. And of course, I would give you a monster number you probably can't do in your head, which is fine. That's fine. So my n is just a 15. So I would do negative 14 times 15 divided by 5, and I would get negative 42. Yes, you're allowed to use calculator. It's not cheating. Totally fine with me. Once you get to Algebra 2, it's fine. Questions on this one? Straightforward. I ask you any term I ask you, you just plug in the number. Okay, so now we're going to get to the difference between arithmetic and geometric. How do you know the difference? Because before we can write a formula, we have to be able to pick out, you know, on your sheet that I gave you, you have to be able to pick out which rule am I supposed to use, arithmetic or geometric? Do I use the top equation or the bottom equation? And here's how you decide. If there's a common difference, it's called an arithmetic sequence. Can you guys underline those words in your notes? So if there's a common difference, it's called an arithmetic sequence. So I'm put a box around common difference. I underlined arithmetic sequence. In Avid, they call this marking up the text, like we're writing on top of our notes, you know, taking good notes. To find this difference, what we have to do is sometimes we're able to pick it out in our heads. Like, let's go back to my simple one. 1, 3, 5, 7, 9. You guys told me that the difference was doing what? What was happening? It was adding 2 each time. If you can't visually see the pattern, like maybe this one where I give you decimals, if you're like, I'm having a really hard time seeing the pattern, here's how you find it. Ready? You pick any point you want, like 20, and you subtract the previous term. So minus what came in front of it. And that's going to be my common difference. So I'm going to get 7.5. So if you can't see it visually, like this one, oh, I knew it was add 2, add 2, add 2, add 2. This one is add 7.5, add 7.5, add 7.5. Everybody okay with that? So if you're not able to see it yourself, you're just going to use that little rule.
Sometimes the difference, can it not be like, is it always going to be the same difference between everyone for this sort of thing?
Okay, great question. So his question was, is it going to be the same difference all the way across? Same difference all the way across. To be considered an arithmetic sequence, yes, it has to be the same all the way across. Geometric sequences are going to have different rules, which we'll do in a minute, because of course they can't be exactly the same. But for you to say, Miss G, this is an arithmetic sequence, it has to be the same pattern the whole way across. So let's try this pattern. What is the common difference? Well, we just found it. So next to common difference, let's put 7.5. And then it's saying, what's the next term? So can you guys do the pattern one time and give me the next term? Will really be a sub 5. Do you think we found it? Oh, well, okay, so 27.5 plus 7.5. Yeah, so it would be 35. 35. I'm keeping you on your toes today. I'm just kidding. 35. Okay, good job. Excellent. So what do we need to do? Well, first we need to determine if it was arithmetic or geometric. Arithmetic is always going to have a common difference, meaning it's going to add or subtract to get to the next number. You guys did a great job. So now we're going to find an iterative rule for it. Well, I'm showing you too much information. I should have come in here beforehand. Okay, there we go. So, iterative rule. We need a couple of pieces of the puzzle. Here's my formula. Can everybody look on their formula sheet that I handed out and look under arithmetic sequence iterative rule? Do we see that it's the exact same as my formula on this slide? Everybody okay? So, we are going to fill in a sub 1 and we're going to fill in z together. What did we say a sub 1 was again? The first term. So everybody look up at my sequence. What's your first term? No, your very first term. 5. So far, so good. Everybody okay with where I'm at? All I did was fill in the a sub 1 with the 5. How did I get the 5? I looked at my iterative rule that they gave me, or I looked at my sequence, and the first term was 5. Now my only other letter I'm missing is D. D is the common difference. So look at your pattern. How do I get from 1 to the next? 1 to the next, 1 to the next. What is D? 7.5. This is the one we did on the last slide. Everybody still okay? 7.5. Good job. If you can't pick that out on your own, do we remember what we're supposed to do? You pick any term you want and subtract it from the one next to it. And that's how you get your D. So here's my very generic iterative rule. Why do I like it in this format? Because I could ask you, what's A100, and you plug in a 100. What's the 10,000th term? You'd plug in a 10,000. See why we like iterative rule? Not hard. You take your original and you're plugging in 2 things. That's it. A sub 1, which they always give you, easy. And then we just had to find D by finding the common difference. Questions? You guys did great. There's one way I could simplify this formula. This might be on a quiz like this, but there's one last thing they might do to it. They might simplify it by just distributing this 7.5. Does that make sense? They might just get rid of those parentheses. No big deal. So we would say 7.5n minus 7.5. And then what could they do one last thing to simplify it completely? Can't get rid of the n's, but we could combine our normal numbers together. So we could say 7.5n minus 2.5. So let me give you a minute just to have that on your paper as well, just so that you know how to fully simplify it all the way down. All right, why do we like this form? Because I can pick any number of n I want to, right? If I get nothing else in your head today, I think I said that like 20 million times. We love iterative rule because you can pick any term you want. Now we're going to use the same sequence, but this time we're going to write the recursive rule. So go to that slide in your notes, and we're going to write the recursive rule. You do not have to have these memorized. That's why I'm giving them to you on paper. You just have to know how to use them. So if here's my recursive rule, I'm at recursive rule underneath arithmetic sequence. This whole first part of the problem stays the same. The only part I'm replacing is D. What did we say D was for this sequence? We've done a couple times now? 7.5. 7.5. You're done. That's it. That's all they want. They just want you to plug in your numbers. That's it. When do I like recursive rule? When you know the previous term, right? That's the only time you like this rule. When I see this a sub n minus 1, what does that mean to you? It means the previous term. So if I'm asking you for the 4th term, you need to know the 3rd term first. If I'm asking you for the 10th term, you need to know the 9th term first. So that's when this rule would work. So not as handy as the other one. You guys did great. So when I ask you to write the rules, what are we plugging in? A sub 1 and D. That's it for iterative rule. Recursive rule, just D. That's it. You wrote rules. Easy. You guys are doing great. Okay, so now let's do an example of each one. I am giving you guys the sequence. I want you to try and tell me the recursive rule and the iterative rule for this sequence. So let me give you a couple seconds to work on it, and let's see. There's only 3 numbers you need to plug into these equations, and you are done. So try that for a minute. So the key question is, did you find D properly? Because if your D is correct, then your problems are going to be correct. Anybody brave want to tell me what they got for D? What do you think, Jolie? -2. Great job, guys. So D is a -2. What's happening? -2, -2, -2. If you didn't know and you had a hard time seeing it, you pick one and you subtract it from the one next to it, and you get -2. So let's plug in my numbers. We said for the first one it stays just like that, except the D is going to change. You're done. The second one, this time I have one extra piece of the puzzle. Looking up there, what do we think my a sub 1 was? What's my first term? 10 plus n minus 1 times negative 2. Everybody okay? Not bad. If you want to simplify it, just for sake of practice, we could distribute. I would get negative 2n plus 2. So we would get negative 2n plus 12. Are they not as bad as they first looked, I hope? They look scary, right? But it's not that bad. Not like logs anyway, not as bad as last chapter. All right, so you guys did great. We've practiced arithmetic sequences for recursive and iterative rules. So the last thing we need to do today is now focus on geometric sequences. See how their formulas are very similar, just a little bit different? So let's talk about what makes something a geometric sequence. In a geometric sequence, each term is found by multiplying the previous term by the same number called a common ratio. Can you guys underline both of those? Multiplying, and we call that a common ratio. So look at my example here. What's your pattern? How do you get from one to the next?
Times 2.
Times 2. So wait, if arithmetic was adding or subtracting, geometric's going to be multiplying and dividing. Very good job.
So,
see how easy that was?
So in this case, it's just like squaring them. Like,
it's not. Not squaring.
Oh,
Yeah. Not squaring, it's timesing. Times by 2, times by 2, times by 2. The pattern is consistent the whole way down. The last one, what was our pattern? Minus 2. Whoa, what happened to my thing?
Not like squaring them, like you know, putting 2 squared, 2/3, 2/4 as you go down. Like for this particular case, not for all.
Okay, yeah. So this one has a very specific pattern. Like each pattern will be a little bit different. But the key that I want you guys getting out of today is arithmetic sequences, you'll add or subtract to get to the next number. Geometric, you're going to multiply or divide to get to the next number. That's how you know which equation to pick. So on your chart right here that I gave you, your handout, next to arithmetic, can you guys write add or subtract? The pattern is add or subtract. And then your geometric, your pattern is going to be multiply or divide. That's how you know which one you're going to pick. So my common ratio is 2. So far so good? All right, so let's try one. It says find the common ratio. And I kind of show it to you. If you don't know how to find the common ratio, it's just like finding the common difference. We're going to pick one, 48. Instead of subtracting by the number in front of it, we are going to divide by the number in front of it. 48 divided by 12 is 4. Your pattern will hold true no matter which ones you pick. Let me try a couple more. What if I do 12 divided by 3? Do I still get 4? Yes. I better. It has to be the same pattern the whole way through. What if I picked 192 divided by 48? Guess what I get? 4. So my R is 4. Now it's asking what's the next term in the sequence. Can you guys try and find that? So it gave me A1, A2, A3, A4. Let's find A5. So you would just take your 192 and what are you doing? How do you get to the next number? Times it by 4. What did we get? 768. Awesome. Good job. Any questions so far? You're doing really great. Okay, so now we're going to try an iterative and recursive rule for a geometric sequence. So look at my formula. How did I get this formula? I looked at my chart. So we're under geometric, and we're trying an iterative rule. So that's the little one that I'm under on my chart here. Out of all of these numbers, which ones am I going to fill in? A1 I'm going to fill in. What other letter am I going to fill in? R. That's it. So you guys try real fast. Fill in my A1. Fill in my R. It's the same one as the last page, yeah. So my A sub 1 is 3, and my R, what's your ratio? 4, right? Times by 4, times by 4, times by 4. So 4 to the n minus 1. You are done. That's it. It just wants you to write the rule. It's giving you the pattern, asking you to write the rule. That was easy. Not bad. Why can I not multiply the 3 times 4? I'm telling you, you're not allowed to do that.
4 is going to an n minus 1.
Good, because the 4 has an exponent. In your order of operations, you always have to do exponents before you do your multiplication, right? PEMDAS, exponents, the E comes before the M, so it has to stay like this. Everybody okay with that? Has to stay like this. So if I said find the 10th term, we'd plug in a 10 minus 1 and get 9. We'd have to do 4 to the 9th power first, then times by the 3 out in front. Everybody okay with that? Old PEMDAS. So we did an iterative rule. Guess what's coming next? What's our other rule? Recursive rule. So I'm just going to stay on this slide and rewrite it with you. So I'm going to do my little squiggle. So let's do a recursive rule. My recursive formula is this. What's the only letter that's going to get filled in? R. Fill in your R, please, and you are done. And my R we said was 4, so it kind of looks funny to have the 4 like hanging out like that. So I would probably put the 4 out in front or put in parentheses, something like that. Good job, easy, easy, easy. We just did that one. Okay, here we go. It says find the 15th term in the geometric sequence. 15th. Look at the ones I gave you. I gave you A1, A2, A3, A4, A5. 15th term. I'm telling you we need to use the iterative rule, but I want to know why do we need to use iterative and not recursive? Okay, so let's put this in here. Recursive, we would need what? What do you need to use recursive? The previous term. So what would be the previous term? We'd need the 14th term. Do I know the 14th term? No. I'm not using recursive. That's yucky. I don't know the 14th term. So I have to use iterative. Remember, iterative is the one with the star. It's the one we like better. It's the one we can use to find any term. So let's all look on our paper. Geometric series iterative rule. So let's write down what we have. Let's highlight the two things that we need to fill in number 4. We need to fill in A sub 1, and we need to fill in R. So Kayla, what's A sub 1? Okay, good. A sub 1 is 1/4. R. I need you guys to find the common ratio. Now let me give you a hint. There's fractions in the beginning. Do I really want to divide fractions? Pick 2 other numbers. You can pick any 2 you want as long as they're right next to each other, right? So how are you getting from 1 to 2? How are you getting from 2 to 4? What's the rule? What's happening? You're multiplying by 2. Do you see how you don't have to even deal with the fractions? You don't have to go there. You can pick any 2 you want to think about the rule. If you don't know the rule, you're going to pick one, divide by the one in front of it, you get 2. Pick one, divide by the one in front of it, you get 2. See how that's how you can always find it, even if you have a hard time seeing it. I just always like to ask myself, can I figure it out without doing the math on paper? Can I say, how do I go from here to here, here to here? Oh yeah, I see it. It's just times 2. So my R is a 2. And you're done. You guys did great. Oh wait, I'm not done. 15th term. What do I do with the 15? Plug it in. We're going to plug it in for n. So let's try. So I don't know. I don't have a calculator, but I think I have this one somewhere. So this becomes 1/4 times 2 to the 14th power. 2 to the 14th power is actually 16384. So when you do 1/4 of that, we get 4,096. Sorry, I cut off part of my number there. 4,096 is your final answer. So whenever I ask you a term and you don't know the previous term, you're thinking iterative rule. Always has to be iterative rule. You're looking on your formula sheet to write down that formula, because I don't expect you to have these memorized. You just have to know how to use them. We fill in what we know. So we filled in A1, we filled in R. And then in this case, they wanted to know the 15th term. So I just plugged in a 15 for N and solved from there. So it's not bad. You may use a calculator. You don't have to do this on your own. So here's, yep, question.
So what was the answer that we got for that?
4,096.
Oh, okay, that makes sense.
Okay, so you're going to keep multiplying by 2, multiplying by 2, times by 2, times by 2, times by 2, till you got to the 15th one, which is 4,096. Good job. The only tricky part comes in, you guys, is when they don't tell you if it's arithmetic or geometric, and you have to figure it out, but it's not hard to figure out. So here's my last little example for you. We have to decide whether it's arithmetic, geometric, or neither. Here's what I mean by that. How are we going to know if it's arithmetic, geometric, or neither? If it's arithmetic, what's your pattern going to look like? Add or subtract. If it's geometric, what's your pattern look like? Multiply or divide. And if it's neither, it doesn't have a pattern. You're not going to be able to find one. So try the first 3. Let me give you a minute to work on that, and then I'll go over the answer. So the reason you have to be able to pick out arithmetic, geometric, or neither is because you don't know what formula to use on your chart until you can recognize, oh, is it my top box with arithmetic or is it my bottom box with geometric? Because they're different formulas, right? So you have to be able to identify which one does it go with. Then using the formula is not so bad. That's not the hard part. All right, let's start at the top. Does anybody think they found the pattern? What do you think, Anna? What are you doing with the -3 though?
You're sorry.
Multiplying by -3. If you weren't able to see that, how can I check? There's 2 ways to check. Ready? The first way is you take one and you subtract it from the one next to it. So -27 minus 9 gave me -36. You'd have to try it again. What about 9 minus a -3? Oh, I got 12. Were those the same numbers? No. So subtracting them was not the right pattern. Remember, add and subtract is your arithmetic. So it's not arithmetic because the subtraction thing didn't work. Let's try the multiply divide. So I'm going to take the 27 divided by 9. I get -3. Let's try another one. 9 divided by -3, -3. Oh, I got one that matched, right? The one that matched was a division problem, which means that it is geometric. So if you cannot see the pattern, and it's okay, some people have an easier time of seeing it than others, you need to try those 2 things. You either subtract the previous term or you divide the previous term to look for a pattern. Does that make sense? You can always check. Let's jump down to the last one because that one was a little easier. How are you getting from 1 to the next term? Adding 4. So that would be arithmetic, right? So the top one we said was geometric because it's multiplying. Bottom one's arithmetic because you're adding. What do we think about the middle one?
It's increasing by it increased by 1 at first, then by 2, and by 3, and progressively gets just asked by 1.
Okay. Is that the same pattern every time though? No. So this one is neither one. Yep, that's an N, neither one. Good job. It did ask you to, state common difference, common ratio, so we already found those. So multiplying by -3, adding 4 at the bottom. And then the next term would just be the 5th term in the sequence, right? Doing the same pattern one more time. So I'm going to skip over that. This is what you're ending Friday with this week, and we will do this again next week too. Like, I'll make sure that this is what we cover at next Wednesday's session. The difference, this says series on it. Here's the difference between a series and a sequence. A sequence looks like this. So this one's called a sequence. These top two are series. Can you guys tell me what you see that's different about them? Good. So series have addition signs in between them. There's one other big difference between sequences and series. Sequences have these dots at the end. What do these dots mean? Keeps going. What do you notice about the series? It stops. It's a set amount of numbers. So that's kind of the big idea that I just want you to have in your brain before you kind of go into Friday. But otherwise, you guys are all set. So you know how to identify if it's geometric or arithmetic, and then you'll use your formula sheet to plug in your numbers. So if you're here in person, you have one more thing to do for me. If you're at home, please make sure to answer the essential question in the Dropbox. Thanks. Bye.